Last but not least is number 13. It is a similarity proof. It says, given the diagram below, prove that triangle ABC is similar to triangle XYZ using a two-column proof. Um, Two-column proofs, if you recall, are going to be a statement and a corresponding reason column. And we're going to label it with the givens. And right there, they tell me what I'm given. So step one is um, uh, diagram. How did I know that? Well, it was given. And I'm going to write diagram with info. With info. Because that's really what I care about. I care about all these numbers. And I'm not going to take the time to write them out. You just tell them, hey, you gave me this diagram with information. I'm going to make use of it. And if you recall, we have three methods for proving triangles are similar. And they were the side-side-side similarity, the side-angle side similarity, and the angle-angle similarity postulate. Here they don't tell me anything about the angles. It's a big mystery, so I can't use angle-angle, and I can't use side-angle-side because I don't have a single angle. This is going to be a side-side-side problem. And what I need to show is that corresponding sides grow at the same rate, that some dilation took place, that they're increasing or decreasing at the same scale factor. So I'm going to use their similarity statement to help me make my statements. So my statement 2 is going to be establishing the equal ratios. So I'm going to start with side AB. I'm going to do side AB divided by the corresponding side XY. First two letters divided by the first two letters. And side AB is 12, and side XY is 8. And if I take that and type it into the calculator, I'm going to get a value. 12 divided by 8 is 1.5. And my reason for doing that is the ratio of sides. Technically corresponding sides, but you can get away with that. And I'm going to do this 2 more times, right? I'm going to do it for the next pair of sides. Now I'm going to do it for the last 2 letters, BC and YZ. So I'll put a statement 3, and I'm going to do side BC divided by the corresponding side YZ. I can tell you side BC is that 19.5. I can tell you side YZ is 13. And I bet you, if I type that into the calculator, I'm going to get 1.5. If you don't, you can't prove it, or you did something wrong. That's a sign that you did something wrong. If they ask you to prove it, it needs to be able to be proved. So if you're not getting equal ratios, you're doing something wrong. You're not comparing corresponding sides. So, yep, here I can say 1.5, and my reason is going to be ratio of sides. Okay, and then I'm just going to start keeping track. That was a side. This was a side. I need one more side. I need one more side fact to kind of wrap this up. And the last side is XZ and AC. And I've been doing the big triangle AC divided by the corresponding smaller triangle XZ. And here that's 16.5 over 11. And I guarantee you, or I bet, 16.5 divided by 11 is 1.5. And 4 is going to be, why did I do that? Why did I write this ratio? Well, I'm just doing a ratio of sides, and I'm writing this to keep track. And now, this is the big payoff. Your last statement, 5, is going to be finishing the proof. You're literally going to copy down what they asked you to prove, you're going to copy down triangle ABC is similar to triangle XYZ. Triangle ABC is similar to triangle XYZ. And how did we know that? What's our reason? You could write me a long paragraph or sentence saying, look, I compared the corresponding sides once, twice, and 3 times, and each of the times I got the same ratio. So corresponding sides, one triangle to the other, have equal ratios, then the triangles need to be similar because that's the definition of dilation, and dilations produce similar figures, and that's why these triangles are similar. That was a mouthful, and I'm sure it's a long essay, but because we are master geometers, we know we can just write side, 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 similarity, postulate. If you're feeling fancy, you can write postulate, but it's really that. And when you write side, 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 SSS, similarity, you're telling the people that are reading your proof everything I just said prior. And it's on them to figure this out. They're going to open up a textbook and look up what you just wrote, SSS, similarity. And when they look at that, all that stuff is going to be cited there. So proofs aren't about, it's not about defining things. It's about writing a clear map or guide to explaining why this is. And we don't need you to write an essay. We just need you to explain all the details and then wrap it up in a nice bow for us. And that's what this problem did. So this is the last of the problems for Elias Academy. I think this is day 56. We're going to do 2 more for the rest of the week. And at the end of each Elias Academy will be another similarity proof. And it'll be a little bit different and a little bit more advanced than the previous. So next time we're going to be talking about side, angle, side. And then the last day we're going to be talking about angle, angle. I'm going to do each of these proofs for you. And thank you. I'll see you in class.